Humans have always been inquisitive about their existence. We are curious about our origins, wonder about the future, and question if we are alone in this vast universe. This innate desire to understand ourselves and the world around us has led us to explore space. Space exploration offers a unique opportunity to discover new frontiers and experience the incredible phenomena that exist beyond our planet. On July 21, 1969, we achieved our dream of landing on the Moon, a significant milestone in human history. It was a small step for a man, but one giant leap for mankind. The accomplishment strengthened our resolve towards space exploration, and today we are aiming to establish permanent stations on nearby celestial bodies. The universe is a fascinating place, but it can also be quite harsh. While the idea of traveling through space between stars is exciting, the reality is that it presents significant challenges and dangers to those who undertake it. Establishing a base on any interstellar body is a difficult task, as space is freezing, with temperatures as low as 270 degrees Celsius, and there is no or very little atmosphere to protect you from the harsh conditions. Galactic radiation, micrometeoroids, and orbital debris are among the major concerns. Additionally, the psychological toll on space travelers due to the immense distances and limited resources at the site cannot be overlooked. The Artemis launch is scheduled for 2025, which has revived interest in traveling to the Moon. However, there are still various technological challenges that need to be addressed, both known and unknown, before establishing a permanent lunar station can become a reality. At first, scientists were primarily interested in sending a pre-built space station, similar to the International Space Station, to the Moon. However, since 2009, when the Japan Aerospace Exploration Agency discovered voids related to drained lava tubes on the lunar surface during the KAGUYA mission, the concept of using them as a potential harbor on the Moon has gained more attention. The proliferation of cave-related planetary studies in the last 2 decades coincided with the advent of high-resolution optical instruments on orbiting and flyby spacecraft, which dramatically improved planetary surface imaging capabilities. Scientists have identified 6 processes that form caves beyond Earth. These include volcanic caves formed by cool or hot eruptions, fracturing due to tectonics or impacts like from asteroids, dissolution, sublimation, suffusion, and landslides. So far, we have identified 200 subsurface access points on the surface of the Moon. Out of these, they are focusing on 16 pits which are believed to be collapsed lava tubes. These lava tubes are formed due to the flow of lava and can extend for long distances beneath the surface of the Moon. The scientists believe that these collapsed lava tubes could potentially connect to extensive lava tube networks. Lunar caves are gaining attention as it is now understood that these large lava tunnels on the surface of the Moon that may be suitable for human habitats. These tunnels are larger than 300 meters in diameter and are located under 40 meters or more of basalt. They have a stable temperature of 20 degrees Celsius. Lunar lava tubes provide protection from cosmic radiation, solar radiation, meteorites, micrometeorites, and ejecta from impacts. They are also insulated from the extreme temperature changes on the lunar surface. Therefore, these tunnels could provide a stable environment for humans to live in. Radar sounder measurements at various locations, including Marius Hills, suggest that there might be tubes on the Moon that are hundreds of meters tall. Additionally, gravity mass deficits with GRAIL and comparative planetology with morphometric analysis of Earth analogs further support their existence. Structural stability models reveal that voids up to 1 kilometer in width can theoretically be stable under only a few meters thick roofs under lunar gravity conditions. However, the real assessment of their stability will come up once the on-site sampling and chemical and physical examination is accessed to determine the actual strength of the structure. The proposed structures of the permanent station is now revolving around these lava tubes. But converting lava tubes into habitable spaces is not an easy task. It requires a significant amount of infrastructure and advanced technological capabilities. Researchers are developing structural models that can fit inside the caves and can be pressurized with breathable air to make them livable. Another approach is to close 2 sections of the lava tube and seal them for pressurization. This can create living spaces bigger than any that can currently be constructed using only manufactured materials. Studies have identified materials for constructing the inflatable station model. The base of the station upon which the inflatable will sit, scientists are considering materials that are abundantly available on the Moon. The Moon's surface as a whole comprises various materials that are native to its surface. They are altogether called regolith. Regolith will be used for shielding the structure from direct radiation, meteoroid impacts, and temperature variations. A minimum of 2.5 meters of regolith cover is required to minimize the radiation levels to human standards. Kevlar is considered for the structure membrane. Kevlar is a synthetic fiber that is incredibly strong and heat-resistant, with a high tensile strength-to-weight ratio. To put it into perspective, it is 5 times stronger than steel. Kevlar 29 is commonly used in ballistic applications. Although Kevlar maintains its strength at cryogenic temperatures as low as 196 degrees Celsius, it loses 20% of its strength at high temperatures. Therefore, scientists are suggesting the use of composites like graphite to address this issue in the lunar conditions. The structure of the base will be of magnesium. Magnesium is abundantly available on the surface of the Moon. It is one of the most easily machinable metals and exhibits excellent casting properties. Magnesium alloys, such as Az91, possess high strength-to-weight ratios and outperform steel. Moreover, magnesium is highly resistant to impact and has 30 times more vibrational damping capacity than aluminum. This feature is particularly useful in mitigating the effects of meteoroid impacts and moonquakes. Aluminum is the preferred material for connecting inflatable membranes and magnesium plates and station components due to its strength, durability, and weight efficiency. The inflatable membrane is strengthened with epoxy to ensure puncture resistance throughout the structure. This is a crucial element because, unlike air, which can cause sudden depressurization and rupture, epoxy helps to maintain and contain pressure even in the presence of minor flaws, which can then be fixed as soon as possible. The race for establishing a permanent moon station between space agencies has added an exciting chapter to the ongoing saga of human space exploration. Our celestial neighbor, the Moon, is once again becoming the focal point for scientific discovery, technological innovation, and international collaboration. As these space agencies set their sights on the lunar frontier, we are in for an exhilarating era of lunar exploration. Hopefully, we will witness the establishment of a lunar station in our lifetimes. Thank you for watching this video.